The talk that I'm presenting here is all about towards an unified API for Spark and the Industrial Internet of Things. And it's all about processing in real time this kind of data, the Industrial Internet of Things, with the new structure streaming API of Spark. Well, let's start with some numbers. For example, General Electric says that IIoT investment is expected to top like $60 trillion during the next 15 years. Accenture, for example, says that it could add like 40 trillion to the global economy by 2020. McKinsey, on the other hand, predicts that Industrial Internet of Things will touch more than the 40% of the global economy by 2025. Finally, about the number of Internet of Things deployed around the world, Gartner says that by 2020 there will be about 20 billion. Well, let's move on to some use cases and key benefits for the industry of this kind of data. It covers all of the product life cycle, from the product development, design, product online, product life cycle. You have like better efficiency, lower the cost, and you have here some of the samples, like for example, after-sales service optimization, overall equipment efficiency, etc. But well, all of these concepts are related to the trend now, like the Industry 4.0 concept. And well, the key, we have some issues processing Industrial Internet of Things data. The overall picture of this kind of architecture is that you have some sensors of IIoT or data sources, whatever you want to call, that usually sends data to an Internet of Things gateway, and then that data is processed in clouds, data centers, etc. Well, our first issue is like usually, if we want to process this kind of data in real time, is that we could have late data or ordering issues, for example, because of connectivity, 2G, 3G, 4G problems, or maybe because the protocol that you use doesn't support ordering. For example, if you use COPE, COPE is UDP-based, and because of that, it can't provide ordering. And on the other hand, you have MQTT. MQTT, some people could say, okay, you could use quality of service level 2 that provides ordering, but most of the brokers out there right now don't support that. For example, the one that Amazon provides you, the Amazon Internet of Things broker, don't support quality of service level 2. On the other hand, we have the data quality. For example, we could have problems with our sensors, and our RAV sensor values are not correct, or maybe we could need to deal with duplicates because our local acquisition systems are not correct, or maybe this is another case for local connectivity issues, etc. Therefore, having a tool that enables us to solve this problem easily is very important. For that, I would like to introduce the Spark Structured API, streaming API. This stream library has been built on top of Spark SQL engine. It tries to unify, to have a unified API for batch and stream processing. And here's an example. You have here, you define a source, for example, in this case, a Kafka topic. You define your transformation. You define your output, the sink. In this case, is another Kafka topic. Finally, you can optionally specify a trigger. This is an example of a structured streaming API query. And well, the important thing here for IIoT data is that this API supports late data and deduplication via event time and watermarking. It also supports aggregations, user-defined functions, and arbitrary stateful operations via map with a state operator. And you can do joins with static data right now, but in the next Spark version 2.3, it will support also joins between different streams. Okay, let's start. I have built a hands-on demo. For this demo, I use a lot of big open source tools. For example, we use NiFi for routing, Kafka for messaging and decoupling, Spark for real-time processing, Cassandra or storage, Mosquito will be our MQTT broker, and Zeppelin will be our web-based notebook for interactive analytics. I have built all of this demo in Docker. I will put later on all of this code is in GitHub if you want to play with it later on. About architectures, here I have sent sensor data from 2 machines to an MQTT broker. This data is in JSON format. For example, we send the machine identifier, its status, the temperature, pressure, and humidity. Okay? From this, or we use NiFi. NiFi ingests the data from incoming data from MQTT broker to Kafka topics. It makes a routing depending the status of the machine. If the machine status is critical, it will send the information to alarm topic. And if it is not in critical status, the data will be sent to another topic. Okay? From there, we are trying to use here Spark for real-time processing. We will use Cassandra for storing raw data or aggregations, or whatever you want, and use Zeppelin in order to interact with, to make interactive web analytics with these notebooks. Well, this kind of architecture usually is called in the IIoT world like digital platforms, like platform as a service. And usually you can run them on any cloud, public cloud, on-premises, or whatever you want. Okay? Let's move this. Well, first, okay. This is NiFi. NiFi, first, you need to load a template. I have built a template for this project. It's also in GitHub. We just select upload template, load it. Very easy. It's imported right now. We just instantiate the template. Well, I think you can see here. Okay, here first, we have a data flow. And this data flow is defined in this way. First, we consume the message from the MQTT broker. Then, as the data is in JSON, we try to evaluate on the machine status here, in this one. And in the next one, the route on alarm, we will route depending the machine status. It is critical, we will send to alarms topic. This is a Kafka publisher. We have another one that's published data, just we publish normal data or when the machine is not in critical status. Well, in order to run this, we just start the data flow. Okay, but now we don't have any data here. Then I will instantiate the producer or fake producer that will try to send to the MQTT broker fake data from 2 machines in real time. Here I have built a small Java program that do that for you. And you just need to put the address, the IP address of your MQTT broker, and just specify the period, or for example, here it will be sending data each 300 milliseconds. Remember that all of this demo is running in your laptop. Don't try to put too lower. Okay, we just start. Oops. Sorry. Demo. Okay. Then after this, after starting the producer, we should see here that, I don't know if it is clear, maybe with zoom. I don't know if you can see it, but now data is flowing. You can have here. Remember that this is in real time right now. Okay. Then after publishing data from Kafka, I will go to the Zeppelin. I don't know, maybe I can increase the size just a little. Okay, better. You have here, I will provide 2 notebooks. The first one is only for trying to play with the structure streaming API of Spark. And the second one called structure Cassandra, you will be playing with structure streaming and Cassandra that right now it's not, it's kind of difficult because you need to make your own writer to Cassandra from Spark streaming. Okay. Just open the first notebook. Here, before using this notebook, you should go to the Spark interpreter and add those dependencies, but I have done already that for not losing time in this demo. Here, for example, I will read a file, a CSV file in data frame, and you can see here that the only difference in code, maybe a little more, okay, maybe too big. But the only difference when you are trying to do a streaming or batch is that here you use read or read stream. For example, if I do this, okay, it's running. You can see here that I have loaded in a data frame data set in CSV format. And I have asked to Spark if this data frame is streaming. Of course, it says not because I use read instead of read streaming. After you have this loaded, I have registered a SQL table, temporary table of Spark called bank. And after that, the good thing of Zeppelin is that you can make interactive queries to this data frame in direct SQL. For example, here I would just want to make the age distribution from this data set. And as you can see here, this is SQL pure. I didn't interact with the Spark. It's just SQL. Standard SQL. And the good thing is that you can have, as you can see here, nice graphs. Another example is like the age distribution of this data set, depending if your marital status. And you can see here another good thing of Zeppelin, like you can make dynamic forms. For example, here you are single, divorced, or married, and you do this, it makes the query again, and it refreshes the graph. This is very interesting for interactive analytics. And well, let's start with the streaming. First, for use the streaming analytics, you need to know first or declare first your schema of the incoming data. Here, as I said before, we have the machine identifier, its status, its timestamp, the timestamp, the temperature, the pressure, and the humidity. We just load the schema. And well, this is our first example of a streaming query. In this streaming query, I will be reading data from Kafka. I will subscribe to both topics, to the alarms and data topic. And well, the thing here is that I want to transform my JSON object to a data frame. And I use this select and from JSON format. In this from JSON, I specify the schema, and I get back a data frame. And in the next row, the thing is that I get the topic. I want to know the topic of the data, where it comes from. And I try to explode the JSON in order to have better results. Here, as a sync, I will write this on memory. This is only for testing. You shouldn't do this for production, but the thing is that, that using this approach, you can use SQL also. Then I will try to run this query. Okay. Then if we go to the Spark web interface, if you are using Spark, this is like your debugger. Here, if you work with the Spark, you know this for sure. But, well, you can see here that our query has started. Here, you see the name, the identifier, and the batch. If I wait, I don't know if that. I put the trigger each 10 seconds. Now it's another job. You can see that it's batch 2. Well, let's see what the data looks like. Okay, I make this one. As you can see here, we can use SQL directly, like, I don't know what happened. This is real-time data incoming from the query. I can order by timestamp. I can refresh the query again. And This is the data that is coming in real time from our fake data producer. Okay, I can make more things. For example, I can add this thing. I will try to get the average of the humidity per topic. And here is a good thing. You have here is a graph. Here, this is the average of the humidity per topic. And here you can see that the average of the humidity for the topic alarms is a lot greater than the data that it comes from the normal topic, data topic. And I did this on purpose, but I mean, with this tool, you could get a really useful insights from your machines if you are having problems. And let's move to another sample. Another cool thing is that, as I have said earlier, this API supports watermarks and late data. And another thing that I didn't tell you is that the fake data producers that I have programmed, they make duplicates, they send the data on address, and well, it's a good thing to do watermarking in event time and drop duplicates if you are using this for IIoT processing. Well, the thing here is that the only thing that changed from the other query is that we have added here 2 lines. We use with watermark, and you need to provide where your timestamp is, what is the column containing the timestamp. Here, I will wait 1 minute for late data. If data arrives later than 1 minute, it will be dropped. And I could also, in the next one, I drop duplicates, and for that, you need to provide the keys. In this case, will be the machine identifier and the timestamp. And of course, here, I will try to do an aggregation. This aggregation will be, I will try to compute in real time the average of the humidity that is the same that in the case before, but I am doing that in the query. Okay, we can start the query. And now, okay, you can see here that this is getting in real time with corrected data. I mean, taking into account late data, dropping duplicates. I mean, this is really useful if you can't have ordered data, you don't know you have duplicates, at least if you are running real-time processing. Moving on, of course, if you want the older streaming API of Spark, you have here another tab called streaming. Right now, you don't have one for Spark structured streaming, but well, you have a useful method that you can show your query last progress. And for example, you have here the timestamp, the number of rows processed per second. You have also the watermark. What is the watermark right now in the query? You can have also if the offsets for Kafka, etc. We'll stop the query. And well, for showing the watermark thing, I have programmed 2 queries. It's the same query, but in one of them I will use watermarking, and in the other one I won't use it. If this an aggregation, I start with aggregation. I'm trying to count in this query, as you can see. I just want to count the number of events per second, how many readings from our machines we have in real time. And this is a very good approach to see why is this interesting, this new API for this kind of data. Let's make the query. And you have here, for example, if I refresh this thing, it will be more points. Right now, we have only two timestamps in a window, but here, you can see here that without watermark, the machine to count is 92, but with watermarks, it's only 44. I mean, the real count is 44, but if you don't use the watermarking feature, your real-time aggregations will be wrong, totally wrong, I mean. Okay. Let's move on to the next notebook. In this notebook, we are playing also with Cassandra. We are adding Cassandra to to our mix. Oops, sorry. Here, before playing with this notebook, you will need to add to the Spark interpreter that dependency, that acts Cassandra driver. I have done that already, and you should also need to set the Cassandra connection host to your Docker IP machine. Well, for playing this demo, first, we will declare it a key space. A key space is the concept on Cassandra like a database. Here I will, as I am running this in my laptop, the replication factor of this key space will be 1. And I'm using the simple strategy for replication and partitioning, but in production you should use a network topology strategy because later on you could add more data centers. Just wait a few seconds. Okay, now I have created the key space, big data space. And the next thing will be create our tables. We will, for this demo, I have built two tables in CQL for Cassandra. The first one will be storing raw data. And the second one will store a real-time aggregation from Spark. In this case, it will be storing the average temperature per machine per timestamp.